Let's talk about how you choose a shard key in practice. This is important because it's going to determine what kind of performance you get from your shard configuration. The first thought is that you need to make sure that there's sufficient cardinality. By that I mean there's a sufficient variety of values. So for instance, if you decided to shard on something where there was only three possible values, then there would be no way for Mongo to spread it across, let's say, 100 shards. So you need to think about whether or not there's sufficient cardinality for it to be a proper shard key. And you can often solve that problem by putting in a secondary part of the key, which has more cardinality than the first part of the key. The second thought is that you kind of want to avoid hot spotting and writes. And hot spotting and writes, just the way the implementation works today, will occur for anything that's monotonically increasing. And I can explain why that is. So if you did sh.status and you looked at those configuration chunks when we went through that earlier part of the lesson, you may have noticed that the first one was set to min key to some value. And then there were a bunch of values for all the other chunks. And then the final one was some value to max key, which is the maximum possible key. And the problem is that when you do an insert of something that's larger, has a larger value than's ever been seen before, for instance, if you decide to shard on the key underscore ID and it's a BSON ID. BSON IDs increase pretty much monotonically, and if you look at them, you'll notice that they just keep increasing, increasing, increasing. That's because the high part of them is actually a timestamp. And so what's going to happen is that every single one, as it gets inserted, is going to be larger than the maximum thing that's ever been seen by the collection before. So it's always going to be assigned to the highest chunk. And what this means is that if you think about it, if you've got these 10 nodes or whatever number of nodes you have in your shard, and you start doing inserts, and you're inserting and you're inserting and you're inserting, the inserts are just going to continue to just hammer this one shard. And then eventually maybe it'll rebalance, but then it'll go to some other shard, right? It doesn't matter. It's always going to hit one shard. Now, if the writes are of low enough frequency, and again, it's always the question of what your access patterns look like, that might be okay. But if the writes are really frequent, then maybe that's not okay. So you ideally want to think about a shard key that isn't monotonically increasing but has sufficient cardinality. And those are two good basic criteria to think about for your shard key. So I'll give you some examples and you can think about it a little bit. Well, let's say that, for instance, we were thinking about sharding an order collection. Billions of orders, they have order IDs, and the order IDs are monotonically increasing. Well, you probably don't want to shard on the order ID. Now, could you shard on the vendor that the order is with? Well, potentially, if the vendor has enough cardinality, that might be a good choice. Now, could you shard on the order date? The order date has the problem that it's probably going to be increasing, and we're going to get some hot spotting on the inserts, so that's probably not a great choice. Could you shard on vendor comma order date? And the answer is yeah, and it might work pretty well because it's probably got a lot of cardinality, and it isn't going to be, even as you add orders for multiple different vendors, different high order vendors, so they're going to be split amongst the different shards due to the vendor order ID being different. And they might have sufficient cardinality to be a good index. Again, depends on your access patterns. Let's think about another one. So let's say you built a photo sharing system and each user has photos and you keep track of some information in the user's collection, all right, with the username and some other authentication information. Maybe a list of albums, maybe some other photos collection. Could you use username as your shard key? And the answer is yes. It's probably got a lot of good properties to it. If you think about it, if the system is mostly parallel with respect to the user, then you've got these different MongoDBs, and if I'm doing something for username Joe, it'll map to this shard, and if I'm doing it for username Bob, maybe it maps to that shard, and that nicely runs in parallel. I like to think about, how is the problem naturally parallel? And if it's naturally parallel against some particular characteristic, that might be a good one to shard against because that's going to give you nice parallelism in your operation. All right, so that's just a few thoughts about the selection of a shard key. Truth is, you have to do this kind of carefully because it is very hard to redo it because you can't change it, and they're immutable. So think about it hard before you do it and make sure that it makes sense. This is the kind of thing where it could make sense to set up a separate machine and do some testing and access pattern analysis before you finally commit to one. All right, let's do a quiz. All right, so let's say you're building a Facebook competitor called Footbook that will be a mobile social network of feet. and you've decided that your primary data structure for posts for the wall will look like this. So you have a username toguy with a post time and a random thought. I'm looking at my feet right now, and it's visible to these things. So thinking about the trade-offs of shard key selection, select the true statements below. Choosing post time as a shard key will cause hot spotting as time progresses. Choosing usernames as the shard key will distribute posts to the wall well across the shards. Choosing visible to as a shard key is illegal, and choosing post time as the shard key suffers from low cardinality.